AP Statistics Quideo, Chapters 1 and 2, Questions Advanced. So, the very first part of this question is very wordy and can be very confusing. For this problem, the only thing you really need to know out of this is the very first line. Individuals with low bone density have a high risk of broken bones, or osteoporosis. Judy, who's 25 years old, has her bone density measured using DEXA. Her results indicate a bone density in the hip of 948 grams per centimeter squared and a standardized score of z equals negative 1.45. In the reference population of 25-year-old women like Judy, the mean bone density in the hip is 956 grams per centimeter squared. So for A, Judy has not taken a statistics class in a few years. Explain to her in simple language what the standardized score tells her about her bone density. So we drew a z-score curve here, and as the problem states, the mean is 956 grams per centimeter squared, so that is right in the middle. Judy, as we will find out later in this problem, is about 1.5 standard deviations, as she is at 948 grams per centimeter squared, very far below. Now, as we found from the very beginning, women with a low score tend to have a higher chance. So, we would say that because Judy has a lower bone density, she has more of a chance for osteoporosis because she's about 1.5 standard deviations below the mean of most women. So for B, we're going to use the information provided to calculate the standard deviation. So we're going to go back to our score from the basic problem of z equals x minus the mean over standard deviation. Now we know the z-score is negative 1.45, and we know that Judy's score is 948 as your x, and the mean is 956. So we're solving for the standard deviation, which we can now make x. So we're going to solve for x. You get negative 1.45 equals negative 8 over x. You multiply by x, and then you divide by negative 1.45, and your x is about 5.5. So your standard deviation is 5.5 grams per centimeter squared.